Good evening. Welcome to today's class. Others are running behind, but we can't wait for them. We have to just continue. All right. Good to have you here. So we'll continue from where we stopped. Continue from where we stopped last week. Try to see how much ground we can cover today. Is this particular module is very wide, and there's a lot of things we need to take a look at. So we talked about buffer overflow. I think I was saying it last um, week that when you talk about buffer overflow, you're talking about um, there's a particular memory allocation for every software that is running. There's a memory allocation, but when the uh, memory that is allocated is overrun, is overflowing, such that particular memory allocation can no longer contain the memory, then we'll call it buffer overflow. Buffer overflow. So we have some steps that are involved in exploiting Windows-based buffer overflow vulnerability. So basically, it's Windows-based. We'll talk about spiking. Number one, you perform spiking. Number two, you perform fuzzing. So number three, identify the offset. Number four, override the AIP register. Number five, identify bad characters. Number six, identify the right module. Number seven, generate shell code. Then number eight, gain root access. Mr. Tony, but you were giving my number and you didn't reach out to me. So, well, let's talk during the week. I think you were giving my number so that we can look at what is really happening together. So, Windows buffer overflow exploitation, you perform spiking. Spiking, it allows attackers to send crafted TCP or UDP packets to the vulnerable server in order to make it crash. So we are trying to make the vulnerable server to crash by sending crafted TCP or UDP. So I'm not sure if if I explained something about TCP or UDP to us, but let me just re-emphasize it now. We have TCP, then we have UDP. TCP is Transmission Control Protocol, while UDP is User Datagram Protocol. Now, these particular protocols are in level, I think that should be level 4 now. We have application, presentation, session, transport. 7654, yes, transport, which is level 4 of the OSI model. So that OSI model is just a system, a model that shows how that is basic networking. It shows how, I don't know if I've sent a material on networking to you. I will have to do that maybe today. There's a short material on networking that I don't know. I don't think I've sent it, so that because really need that information. You need to get I mean, they give you a head start when it comes to the issue of uh, when it comes to the issue of networking, understanding concepts in networking. So, um, so please, I will do that. I'll send that to the group chat. I'll send that to the group chat. Okay. Sorry, I need to. All right. Oh, okay. Now, when we talk about TCP, TCP is reliable. At that layer, there is transportation, does movement of data from one device to the other. We call it transport layer. Now, at that layer, you have what's it called? TCP, which is Transmission Control Protocol, is a reliable, what we call reliable uh, connection because it ensures before it starts transmitting data, it ensures that the person it is sending data to is available. And how does it do it? It does this thing through the three-way handshake. Now, the three-way handshake, it sends, it receives reply, then it now confirms. So that's the three-way handshake. So that makes the connection to be reliable. So, but UDP doesn't check; it just sends message. So UDP is used usually for live streaming, video streaming, and audio streaming. So, but TCP is used for other more reliable or other connections that need reliable connections. So that's what TCP is usually used for. So that's just a brief. So spiking allows attackers to send crafted TCP or UDP packets to the vulnerable server in order to make it crash. So spiking helps attackers to identify buffer overflow vulnerabilities in the target applications. It helps the attackers to identify buffer overflow vulnerabilities in the target application. So how is spiking spike to perform spike? Okay. Okay. I thought there would be something. Just give me a minute. Let me check something. Oh, okay. So we have spiking. So allows attacker to send crafted TCP or UDP packets to the vulnerable server to make it crash. So that's what spiking is all about. Want to try to make the target server to crash. So the following steps are involved. You establish a connection with the vulnerable server using netcat. Netcat. So that's all these things are in parrot. So I believe very soon I'm working on a way to be able to at least show us this about if you have installed the parrot, but if you have any issue with the parrot, we can always talk during the week, Mr. Tony. I think the other man, Mr. Sam, already has this covered. So, but Mr. Tony, we can work on that. So you establish a connection with using netcat, then you generate spike templates. Define the package format used for communicating. They are useful for testing and identifying functions vulnerable to buffer overflow. Use the following spike template for spiking on the stats function. You send the packages to the vulnerable server using the following command: generate send TCP target IP target port. So generic send TCP, the IP, the port, stats dot spk. That's the spy script, and that's how it spies it. Welcome to vulnerable server send enforcing vulnerable variable O2 So it sends crafted packets to it, and you use the immunity debugger to check. Immunity debugger shows running status of vulnerable server. So that's the target in this place was the stats function. You can see the stats function was what we're targeting to bring down in this particular place. So after identifying that stats function is not for buffer overflow, we repeat the same process for the Tron function. Use the following spike template. So we will target Tron using this following template. Tron spike template. Then we'll use Tron. You can see Tron is being used there. In this place, the target was stats. So from here, we can see it has buffer overflow vulnerability. Spiking this function overrides stack registers such as EAX, ESP, EBP, and EIP. If attackers can override the EIP register, they can gain shell access to the target system. So using immunity debugger, we see that the vulnerable server has paused. So before it was running, but now it has paused because of the attack that was carried out against it. So so the first step is spiking. Then the number two step is fuzzing. After identifying the buffer overflow vulnerability in the target server, we must perform fuzzing. So attackers use fuzzing. Anytime you have fuzzing, fuzzing is not only for buffer overflow, it has many other uses across different levels. So fuzzing, you send large amount of data so that you can uh, create an error message. And that error message is what will give you the insight into the kind of things that are happening on the system. So fuzzing helps in identifying the number of bytes required to crash the target server. This information helps in determining the exact location of the IP register, which helps in injecting malicious shell code. So the screenshot below shows example Python scripts used by attackers to perform fuzzing. So Python scripts used to perform fuzzing. When you execute the above code, buff multiplies for every iteration of the while loop and sends the buff data to the vulnerable server. As shown in the screenshots, the vulnerable server crashed after receiving approximately 2,300 bytes of data, but it did not overwrite the EIP register. So fuzzing crashed the vulnerable server. So you can see from the immunity debugger, it shows that it has paused, meaning that the thing has crashed. Then number three step is we have to identify the offset. So through fuzzing, we have understood that we can override the IP register with 1 to 2,300 bytes of data. Now we use the following pattern create Ruby 2 to generate random bytes of data. User share Metasploit framework tools exploit pattern underscore create dot RB 1 3000. So this is we want to identify the offset. We are creating this script. Screenshot showing Metasploit pattern, create output. So here, we'll copy it into this place. Copy it into this place and use it to send random bytes to the server. So when the above script is executed, random bytes of data are sent to the target vulnerable server, which causes buffer overflow in the stack. The screenshot clearly shows that the IP register is overwritten with random bytes. You must note down the random bytes in EIP and find the offset of those bytes. So buffer overflow of vulnerable servers overwritten EIP register with random bytes. also have to, the next step is to overwrite the EIP register. The EIP register is at an offset of 2003 bytes, 2003 bytes. Now run the following Python script to check whether we can control the EIP register. The EIP register can be controlled and overwritten with malicious code. So this it shows you can see the EIP is overwritten with 4 Ds, ASCII value 44. So you now identify bad character. Before injecting the shellcode into the EIP register, you must first identify bad characters that can cause issues in the shellcode. You can obtain the bad chars through a Google search. Characters such as no byte, that is quotation mark /x00 are bad chars. So you can see them here. X00, they are bad chars. So you now run this Python script to send bad chars along with the shell code. In Immunity Debugger, right click on ESP register value, then click on following dump, and finally observe the characters. You'll find that there are bad chars that create problems in the shell code. So return-oriented programming. So all these things that we're talking about, they are just ways for us to attack. Where the whole target here is system hacking, trying to hack a system. All of us started with the issue of password cracking. Talked about password cracking. So when we started talking about the issue of password cracking, that's the first thing, because after enumeration and the is able to have gotten maybe what's it called, the users, the groups, and all other things. The next thing is for him to uh, what's it called, to try to because when you get the user, what you want to do next is that, you get login pages. So I remember that in the process of enumeration, you have got a username and password. So because of the username and password you have been able to obtain, you get to login pages. The next thing, you need to crack the password, because you have the username but you don't have the password, and that's why password attacks now come into play. So return-oriented programming is an exploitation technique used by attackers to execute arbitrary malicious code. So an attacker hijacks the target program control flow by gaining access to the core stack and then executes arbitrary machine instructions by using available libraries known as gadgets. So gadgets are a collection of instructions that end with x86 RET instruction. So we have malicious app uses buffer overflow to corrupt stack frames. You can see the malicious function. Then the call gadgets, the library function A, then pop address of gadget B, then pop the address of gadget C from the stack and return it. So return-oriented programming. So gadgets are a collection of instructions that end with x86 RET instruction. The attacker selects a chain of existing gadgets to create a new program and executes it with malicious intention. So return-oriented programming attacks are very effective as they utilize available and legal libraries which are not identified by security protections such as code sign and executable space protection. So using this technique of return-oriented programming, The attacker hijacks the target program control flow by gaining access to the core stack and executes arbitrary machine instruction by reusing available libraries known as gadgets. Gadgets are a collection of instructions that end with the x86 RET instruction. The attacker selects a chain of existing gadgets to create a new program and executes it with malicious intention. Further, the attacker can also perform code branching and search for conditions such as equal, less than, and greater than on the program data. So our return-oriented program attacks are very effective as they utilize available and legal code libraries, which are not identified by security protection such as code signing and executable space protection. And exploit chaining. We'll talk about exploits when we were talking about. Okay, we have not. I think okay, we are yet to talk about vulnerable. I think we talked about vulnerabilities. Have we not talked about vulnerabilities? I think yes, we talked about that. That was the last one before we got here. So every vulnerability that you see, it's before you can uh, take advantage of any vulnerability. Before you can take advantage of any vulnerability, you need an exploit. An exploit is what we will use to take advantage of vulnerabilities. You use exploits. So, exploit chain is a process of combining different exploits to be able to take advantage or to take advantage or uh, to infiltrate and compromise the target from its root level. So, exploit chaining, also known as vulnerability chaining, is a cyber attack that combines various exploits of vulnerability. So, for instance, is Windows system, maybe Windows 10, Windows 7, Windows 8 has two or three or four vulnerabilities. Let's say, for example. So instead of exploiting just one of those vulnerabilities, you exploit like two or three at once, such that if one escapes, the other one will not escape. So during exploit chain, an attacker first initiates a reconnaissance operation and then starts enumerating various digital footprints and underlying vulnerabilities one after another within the software or hardware of the target system. So, number one, he initiates reconnaissance. Remember, we say reconnaissance is gathering information. You gather information uh, about your target. You gather information. Then, number two, you gather exploits one after another. Gather different exploits that you can use to take advantage of those vulnerabilities. Then number three, you now combine all the exploits. You have exploit one, exploit two, exploit three, exploit n to compromise the system. Then you now gain access to root level services. So that is what exploit chaining is all about. So if you look at the different vulnerabilities that are existing, then you start looking at exploit chaining. Exploit chaining, looking at different exploits, then you combine them. Don't just use one. You combine them to be able to do what you want to do. Organizations face considerable risk because of exploit chains. Exploit chains are typically carried out swiftly, and most businesses lack the necessary playbooks, policies, and resources to effectively block or limit the threat. Exploit chains leverage known vulnerabilities to form chains, which puts IT assets at risk as they cannot be identified and mitigated easily. Then we talk about Active Directory. Active Directory. Attackers perform Active Directory enumeration to extract sensitive information such as users, groups, domains, and other resources from the target Active Directory environments. So attackers enumerate Active Directory using PowerShell tools such as PowerView. So we want to enumerate domains. So domains, a group of systems. That's what you refer to as domains. So you have a group of systems that are working together, maybe in a particular unit or a particular office, they will belong to a single domain. So command get add domain retrieves information related to the current domain, including its domain controllers. Get domain SID retrieves the session ID of the current domain. Then enumerating domain users. Command get net user retrieves information related to the current domain user. Then get logged on computer name retrieves information related to the current active domain users. Then get user properties PWD last set. Retrieve the date and time of the password last set for each domain user. Find local admin access. Retrieve users having local administrative privileges in the current domain. Invoke enumerate local admin requires administrator privileges to run. So enumerating domain policy, get domain policy retrieves the policy used by the current domain. Then get domain policy system access retrieves information related to the policy configuration of the domain system access. Then get domain policy Kerberos policy retrieves information related to domains Kerberos policy. So power view, get net domain. This is an example of get net domain, which is to retrieve information related to the current domain, including the domain controllers. So you look at the domain, forestch.com domain controller, then children, domain mode unknown, domain mode level, parents, PDC role owner, RID role owner, and so on and so. So that's a particular domain. Then another one, get domain controller, forestch.com, OS version, Windows Server 2022, domain ch.com scheme, and all that. So enumerating domain shares, you want to look at the things that are being shared. Name of the share, computer name, and type of share. Invoke share finder variables, retrieves shares on the hosts in the current domain. Get net share, retrieves all the network shares existing in the current domain. Get net file server variables, retrieves the file server of the current domain. Invoke file finder, retrieves all the files in the current domain, including files that store credentials. So that's invoke file finder. Get net file. So look at the example of invoke share finder here. So it's able to look at the different files that are being shared, all the files in the current domain, including files that store credentials. So different files. This one admin, remote admin, C, default share, IPC, remote IPC, net logon, remote logon server share, and so on. So organizational unit is a subdivision of the Active Directory used for categorizing users, groups, and computers. It helps administrators define a specific group policy for all the users, groups, and computers that fall under the organizational unit. Attackers enumerate organizational units to identify instance type, object, GUID, and object category. And so on and so forth. So much there. So we can use Bloodhound to do domain mapping. Active Directory domain mapping provides the barrel architecture of an Active Directory domains structure present in an organization in a GUI format. So bloodhounds, attackers attempt to identify complex attack paths in the target organization's active domain using tools such as bloodhound and DocuSnap. Bloodhound uses graph theory to review the hidden and often unintended relationship within an Active Directory environment. So Bloodhound, JavaScript web application built on top of Linkurious and compiled using Electron with a Neo4j database fed by a C++ data collector. Uses graph theory to reveal hidden and often unintended relationship within an Active Directory environment. Easy to easily identify complex attack paths in Active Directory environments. So with this, an attacker will be able to identify an attack path. You can see this blue line indicates the path through which the attacker can attack. Okay, buffer overflow detection tools. Only DGG dynamically traces stack frames and program execution, and it logs arguments of known functions. So if you want to identify, want to easily detect buffer overflow vulnerable applications, you can use only DBG. Other tools are Veracode, Flow Finder, Q1, Splint, Ghosted. So only DBG 32 bits. You can find out an only dbg.de assembly level analyzing debugger for Microsoft Windows. Its emphasis on binary code analysis makes it particularly useful when the source is unavailable. It debugs multi-thread applications and attaches to running programs. It recognizes complex code constructs such as call to jump to the procedure. Dynamically traces stack frames and program execution and logs arguments of known functions. So it looks at different applications that are running to detect what is happening if there's buffer overflow ongoing or if buffer overflow is taking place. So how do you defend against buffer overflow? Develop programs by following secure coding practices and guidelines. So these are for developers, people that are into programming, software development. They will understand it. Develop program by following secure coding practices and guidelines. They use the address space layout randomization technique. Validate arguments and minimize code that requires root privileges. Perform code review at the source code level by using static and dynamic code analyzers. Then allow the compiler to add bound to all the buffers so that there will be no overflow. Once there is bound, it won't overflow. Then implement automatic bounds checking. Always protect the return pointer on the stack. Never allow the execution of code outside the code space. Regularly patch application. Very, very important. Applications need to be patched. An operating system, then perform code inspection manually with a checklist to ensure that the code meets certain criteria. Employ data execution prevention to mark the memory regions as non-executable. So remember that these memory regions are where the attackers try to perform spiking and all other attacks. So we mark those places as non-executable. Then implement code pointer integrity, checking to detect whether a code pointer has been corrupted before it is dereferenced. So we want to talk about privilege escalation. Privilege escalation. Basically, we have talked about password attacks, talked about the issue of buffer overflow. Those are the two things we have talked about when it comes to system hacking. But another thing in system hacking is privilege escalation. What do you mean by privilege escalation? The attacker may be able to get into the system, gain access with a what's it called? An ordinary level what's it called? Ordinary level account. That's an account, the ordinary account that can't do much. You can't install, you can't uninstall, you can't do so many things because you have to have admin level access to be able to install applications and all that. So And without uh, administrator level, the attacker cannot install. He wants to have access. He wants to be able to install rootkits. Those rootkits allow him to be able to come in whenever he wants. So they allow him to come in whenever he wants into the system. Then he wants to be able to install maybe some malware that will allow him to uh, be able to maybe get information, exfiltrate data, even from the target system and all that. So, but without having administrator level account, he can't be able to do that. So that's why even if he gets in into the system with ordinary user level account, he will want to escalate his privilege so that he has higher privileges and can do and undo. So attacker gain access to the network using a non-admin user account, and the next step will be to gain administrative privileges. So non-admin user account, that's ordinary level account. Then he wants to gain administrative privilege. The attacker perform privilege escalation attack that takes advantage of design flaws, programming errors, bugs, and configuration oversight in the operating system and software application to gain administrative access to the network and its associated applications. These privileges allow the attacker to view critical or sensitive information, delete files, or install malicious programs such as viruses, trojans, or worms. So that's what they allow him to do, just like I've emphasized just now. So those viruses, trojans, or worms are referred to as malware. So we have two types of privilege escalation. We have the horizontal. It refers to acquiring the same privileges that have already been granted by assuming the identity of another user with the same privilege. Then another one is gaining higher privileges than those existing. So if he's able to get an admin level account, that's horizontal. Then vertical, he gains a normal or user level account, but he is able to now add to the privilege of that account. So that's vertical. Vertical. So there's ways you can try to escalate privilege. Number one, we have what we call dynamic libraries. Dynamic libraries work with uh, what's it called? They work with application. Every application has a form of dynamic library that allows it to run. It allows the application to run. So most Windows applications do not use fully qualified path when loading an external DLL library. Instead, they search the directory from which they have been loaded. If attackers can place a malicious DLL in the application directory to be executed in place of the real one, attackers use tools such as Robber and PowerSploit to detect hijackable DLLs and perform the hijacking on the target system. So the user installs the application. We have the .exe file, the malicious DLL. So but it doesn't allow, it blocks the real DLL that is required by the exe application. It loads the malicious DLL instead of the real DLL. So the attacker places the malicious DLL in the application. He gains remote access to the system. So Robber is an open source tool that helps attackers to find executables that are prone to DLL hijacking. Robber, you can get that from GitHub. It tells attackers to find executables prone to DLL hijacking. Attackers use Robber to find out the DLLs are executable requests without an absolute path. So attackers can then place their malicious DLL high up in the search path so that it gets invoked before the original DLL. So all these ones, they are, you can easily inject the DLS to them. Then you can also do privilege escalation using exploits. So you have the exploit database exploit-db.com. The attackers exploit software vulnerability by taking advantage of programming flaws in a program, service, or within the operating system, software, or kernel to execute malicious code. Exploiting software vulnerabilities allows the attacker to execute a command or binary on a target machine to gain higher privileges than those existing or to bypass security mechanisms. So attackers using these exploits can access privileged accounts and credentials. So attackers search for an exploit based on operating system and software application on exploit sites. So we have this exploit site. Please take note of these sites. They are sites that you will need. So based on the flow of this particular course, the way it is that you for if you have a target that you want to, if you have a target in mind now that you want to attack, you gather information about that target. When you gather information about the target, you want to know as much as possible. You want to know the operating system, you want to know the ports that are open, you want to know the what's it called, the services that are running on the port. So then you want to know the operating system on that particular system. The next thing will be for you to search on exploit-db or VOD-db to know the type of uh, weaknesses that can be exploited on from the information you have gathered on the kind of technology that is being used on the target system. So that's the next thing you would do. So you can get that information. Some people have already been able to get this information, but be mindful of the fact that some of these things may have been blocked or they may no longer be expected. So if you find one that is still fresh, they may not have been blocked, or the target operating system, they didn't patch their system, or they didn't use the latest updates. So that can make it vulnerable. Privilege escalation, you can see different things. You can see the platform, it can be Windows. So anything you see local, that means you have to be close, you have to be in the same network with that target. But this one, like remote, you can do it remotely, anything you can see. Then this one is web application, local. You can see the platform Linux and all those things. So those are the different things. So this dial-lib is the same as DLL in Windows. Windows says DLL, but dial-lib is using Mac operating system. You talk about privilege escalation. Remember, we just talked about DLL hijacking, but here we'll be talking about what's it called? DLL. I mean, dial-lib. Sorry. So it's the same thing. Instead of loading the real dial-lib, it will load the one that the attacker has injected into it. So when application load an external dynamic IP, loader searches for the dial-lib in multiple directories. If attacker can inject malicious dial-lib dynamic library into one of the primary directory to be executed in place of the original dynamic library. So you can use dynamic library hijack scanner and dynamic dial-lib hijack scanner. Helps attackers to detect dial-libs that are vulnerable to hijacking attacks. We have other types of vulnerability, Spectre and Meltdown. Spectre attackers take advantage of vulnerability to read adjacent memory locations of a process and access information for which he or she is not authorized. Using this vulnerability, attacker can even read the kernel memory or perform a web-based attack using JavaScript. So attackers may take then for meltdown. For Spectre, they are reading adjacent memory location to access information which they are not authorized. In meltdown, they can take advantage forcing an unprivileged process to read adjacent memory locations. It leads to revealing critical system information such as credentials and private keys. Just give me a minute. Okay, there's a what we call named pipe. That's another method. I'll just be running through these things, then highlighting the ones that are key. Name pipe impersonation. Windows operating system name pipes provide legitimate communication between running processes. So when two processes are running within Windows, one name pipe helps both of them to communicate. So attackers exploit this technique to escalate privilege on the victim system to those of a user account having higher access privilege. But the processes are communicating, so they now use that name pipe to escalate privilege. So attackers use tools such as Metasploit to perform name pipe impersonation on the target host. Attackers use the command Metasploit commands such as system to gain administrative level privileges and extract password hashes of the admin stroke user account. If process A wants to send a message to process B, process A writes the message to a file, and process B reads the message from that file. So attackers often exploit this technique to escalate privilege of victim system to a user account data privilege. So when a process creates a pipe in a Windows system, it will act as a pipe server. If another process wants to communicate with the process, it will connect to this pipe and becomes the pipe client. So when a client connects to the pipe server can utilize the access privileges and security concept of the context of the pipe client. So attackers exploit this feature by creating a pipe server with fewer privileges and trying to connect the client with higher privileges than server. So using because normal, attackers they it's not as if they are creating anything new. What attackers usually use are things that are already existing, processes that are already available within uh, a I mean, Windows, there are many of the things they use are normal things that administrators use even for the running of the system. So, for instance, this main pipe now is just a kind of communication link. So, when two processes are running, there's a name pipe that is created. So, for the person that wants to receive the information is the pipe client. The person that wants to get the information, that they are getting the information from is the pipe server. So with this particular level of communication, attackers can take advantage and um, use that name pipe to increase their privilege, from user account to administrative level account. So they use Metasploit. This Metasploit console. So they use get system T. Get user ID. You can see techniques, name pipe impersonation in memory. So with that, it's not able to get. Once you see this user ID 500, that is administrative level account. Anytime you are seeing different user IDs, anything 500, especially in Windows system. So, and look at it, it dumped the password hashes. Then you can perform privilege escalation by exploiting misconfigured services. When you talk about unquoted service paths, so normally service paths are supposed to be in a quotation marks, but when they are not in quotation mark, attackers can inject their own there. When they are not in quotation mark, you can inject their own then and replace it. So attackers exploit services with unquoted paths running under system privileges to elevate their privileges. So the service object permission means configure service permissions may allow an attacker to modify or reconfigure the attributes associated with that service. By exploiting such services, attackers can even add new users to the local administrator group and then hijack the new account to elevate their privileges. So you can add new accounts when you have service misconfigured service permissions to modify or reconfigure the attributes associated with that service. So there are different services. Then unattended installs. Unattended install details such as configuration settings used during the installation process are stored in unattend.xml. It is stored in one of the following locations: Windows stroke Panther, Windows Panther unattend GC, Windows 30, System 32, Windows System 32 sysprep. So attackers exploit information stored in unattend.xml to escalate privileges. So when you have um, unattended store details such as configuration details, attackers can use it to exploit, I mean to escalate privileges. So we also have another system they use to call it pivoting and relaying to hack external machines. So attackers use the pivoting technique to compromise the system, gain remote shell access on it, and further bypass the firewall to pivot via the compromised system to access other vulnerable systems in the network. So attackers use the relaying technique to access resources present on other systems via the compromised system, such a way that the requests to access the resources are coming from the initially compromised system. So we have pivoting and we have relaying. So number one, pivoting, the attacker compromises a system that's client one. So he now exploits vulnerability to access client two, as establishing a tunnel session to client two via client one. So that's pivoting. That's pivoting. So, but in relaying, it compromises the system and uses port forwarding rules to access the second system. And he established a tunnel session through the client one and access resources. So, pivoting, there is no direct link to the second system, but in relaying, there's a direct what's it called? Direct link. Attackers use the link tag to access resources present on other systems via the compromised system, such a way that requests to access the resources are coming from the initially compromised system. So to pivot, to relay, you set up port forwarding rules. In the pivoting technique, only the systems accessible through the compromised systems are exploited. Whereas in the relaying technique, the resources accessible through the compromised system are explored or accessed. So I come back again. In pivoting technique, only the systems accessible through the compromised system are exploited. Whereas in the relaying technique, the resources accessible through the compromised system are explored or accessed. So using pivoting, attackers can open a remote shell on the target system, tunnel through the initial shell on the compromised system. In relaying, resources present on other systems are accessed through a tunnel shell session on the compromised system. So pivoting the access in relaying, they can be able to access resources, but everything has to go through the initially compromised system, which is number one system. So in pivoting, the first objective of the attacker is to compromise the system to gain the main shell and further bypass the firewall to pivot through the compromised system and gain access. So once the system is successfully compromised, a meta-preter session is established. As the session is pivoted through the compromised system, the target system cannot determine the actual origin of the exploitation. So the attack will seem to be coming from the compromised system, meanwhile, it is coming from the attacker. It's coming from the attacker. So, number one, for pivoting, you discover the live hosts. So, app scan is performed to discover the list of live systems in the network. So, the attacker uses the following command: run post windows gather app scanner r host target subnet group. So app scanning. So I don't know if I've talked about app before. App is just basically address resolution protocol, resolving physical address to MAC address. No, sorry, resolving logical address to MAC address. That's app. So if two systems want to communicate on a particular network, they communicate, of course, the IP addresses. When they come into the system, the dynamic host configuration protocol or maybe static may be set and IP addresses will be allocated to them. So, but when they want to now communicate within the network, let's say a switch network, the message will be sent and the switch will ask, okay, who is this particular person? And that person will respond with the MAC address. So the switch will now store that information in his CAM table saying, okay, this person has this IP address and this is the MAC address. So anytime there's any other information for the person, it will just look at the MAC address table and forward the information directly to that person. So address resolution protocol is the system whereby um, physical addresses, which are the MAC addresses. So the MAC addresses are usually unique to a computer. No two computers have the same MAC address. So, but IP address, you can have any IP address depending on the network. You can have any IP address. So, but on a network, two systems cannot have the same IP address. So on a particular network. So, but anywhere in the world, all systems have unique IP addresses. Okay, so let's go through this module is quite wide. We can't really touch and explain every detail. We can't really explain every detail. Then there are so many privilege escalation techniques. Probably so many. Privilege escalation using misconfigured network file system can be used to gain root level access to remote server. Misconfigured NFS paves way for the attacker to gain root level access through a regular user account or no privilege. So with that, if it is misconfigured, this NFS is misconfigured. This is one of the things we were enumerating in when we're talking about enumeration NFS. Let me try and see if I can get 2049. That's the port number. So the attacker can use it. So Attacker often attempt to enumerate misconfiguration in network files. Please always mute your mic. Okay, sorry for that disruption. We can't afford distraction. So it uses port 2049. NFS is used to share and access data and files over a secured intranet. Intranet, that is not the worldwide internet, but intranet, that's the internet within a network, within a network. So it uses port 2049 to provide communication between the client server through the remote procedure call. So a misconfigured NFS paves the way for attackers to gain root level access through regular user accounts or role privileged user. By exploiting the NFS vulnerabilities, attackers can sniff sensitive data and files passing through internet and launch further attacks. So we have different users using this remote procedure call to access the network file system. So attackers can target any of them. So once it's able to guide any of them, you can use that one to escalate its privilege. It targets regular users to attain root level access. So once he's able to get them, he will be able to do that. So we have number one, run the following mmap command. Mmap SV target IP address helps us to know the ports that are open. Spot scanning. So here we can see that 2049 is open NFS. So that's number one. Then you have to know if that is running first. If it's not running, then you can't, there's nothing you can do about that. But for this particular case, it is running. Use the following command to install NFS and interact with the target NFS service. Sudo apt get install NFS common. Sudo apt get NFS common. Then run the following command to check if any share is available for mounting and target show mount E. So the same IP address 10.10.1.9. So if the above command returns any mountable directory, you create a directory named NFS. So you make a directory, then run the following command to mount the NFS directory on the target host. So you want to mount it on target host, then execute the following command to view details of mounted directory and obtain the group ownership of the shared directory. Then run the following command to establish a remote connection with target host using SSH. So SSH L Ubuntu 10.10.19. Okay, so that's how that works. So then another way to escalate privilege is using what we call Windows sticky keys. Windows sticky keys. So now Windows, if you are rebooting your Windows, so it allows users to use a combination of Control, Alt, and Shift instead of pressing three keys at a time. So after gaining access to remote system, attackers escalate privilege by simply altering the file associated with the sticky key features and pressing the Shift key 5 times in rapid succession once that system has been booted. So they will change there's a file sticky keys. So you must copy the file sthec.exe at the location system that's to different location. Then must copy command.exe to replace this thing, because normally when you want to use that sticky keys, this is what initiates it. But now you want this command.exe to replace this sthc.exe. So when you restart that system and you press a shift key 5 times, it's instead of loading this one has been moved to the location of this. It loads this and it loads it with administrator privilege. You can see, let me see the screenshot here. You can see it loads a command interface, a terminal, and you can see it's administrator, so admin level privilege. So you can also bypass user account control, privilege escalation by bypassing user account control. Put or login initialization. You can do privilege escalation using that. You can also do it by modifying domain policy. You can also do it by retrieving password hashes of other domain controllers using the CSync attack. So this particular type of attacker initially compromises and obtains privileged account access with domain replication rights, activates replication protocols to create a virtual domain controller similar to the original active domain. So it allows an attacker to send requests to the domain controller, retrieve administrator NTLM password hashes, and perform further attacks such as golden ticket attack, account manipulation, and leaving off the land attacks. So attackers leverage mimikatz to perform this sync. So attacker discovers and mimics domain controller via MS-DRSR. Then he requests replication using get NC changes. Then this provides NTLM password hashes. So what they're able to do is to dump or to retrieve the password hashes of other domain controllers. So with that, they're able to gain administrator privilege. When they get those password hashes, they will just find a way. They can use rainbow table to uh, get the clear text password and use it to log in. So we have this is sync attack. It's performed in following stage. We start from lower privilege and proceed to high privileges. So we have stage 1, you perform external reconnaissance. Stage 2, you compromise the targeted machine. You perform internal reconnaissance. You escalate local privileges. You compromise credentials by sending commands to domain controller. Perform admin level reconnaissance. Then perform malicious remote code execution. Gain domain admin credentials. Other privilege escalation techniques: access token manipulation. Windows uses access tokens to determine security context of a process or thread. So attackers can obtain access tokens of other users or generate spoof tokens to escalate privileges and perform malicious activities while evading detection. So access token manipulation. So access token determines the security context of a given process or thread. So if attackers either spoof it or gain access to the tokens, then they can use it to generate to escalate their privilege. And parent PID spoofing: appropriate PID can be set to process that derive from the system through system processors, SVC, also consent.exe using the Windows user access control security features. Attackers abuse this to bypass security mechanisms that restrict process spawning from the parent and maintain persistence to elevate their privilege. Other privilege escalation techniques are business accessibility, SID history injection, COM hijacking, scheduled tasks in Windows. You have Windows Task Scheduler. So attackers can use the technique to execute malicious program and system startups. So we have some scheduled tasks that do take place. So Attackers can try to uh, execute malicious programs and system startup, maintain persistence, and perform remote execution because there are some particular tasks that have to take place every time the system is booted. So if the attacker is able to gain access and be able to change or edit this, he can try to do that. Then schedule tasks in Linux. Linux utilizes cron or cron an instruction-based utility for automating task scheduling. Attackers escalate system privileges by making changes to the script executed by cron located etc or cron tab. Let's leave this issue of privilege escalations and let's just look at the tools. We have dboot. It's a post exploitation tool to check common misconfigurations, find a way to escalate privilege. Remember, one of the ways you can escalate privilege is through service misconfigurations. So when you have misconfigurations, so but B root, a post exploitation tool to check common misconfigurations to find a way to escalate privilege. Then we have limpo stacks obtains detailed information on the kernel, which can be used to escalate privileges on the target system. So the kernel is like the framework that is used to build the software, the operating system. So broot.exe, Windows privilege escalation, bang bang. It looks for what's it called? Different services that are misconfigured and can be taken advantage of. So it talks about look and see. Task scheduler, startup keys. Those are the different misconfigurations that have the service. How do we defend against privilege escalation? Restrict interactive logon privileges. Restrict interactive logon privileges. Run users and application with lowest privilege. That means every application you are running, make it the ordinary user account so that even if the person is able to gain access to that user account, he can't use it to escalate his privilege. Then implement multi-factor authentication and authorization. Run services as unprivileged accounts. Implement a privilege separation methodology to limit the scope of program errors and bugs. Use encryption technique to protect sensitive data. Reduce the amount of code that runs with a particular privilege. Perform debugging using bounce checkers and stress tests. Thoroughly test the system for application coding errors and bugs. Then regularly patch and update the kernel. So very, very key. If you forget anything, don't forget patching and updating. So that's very important, especially on our systems. Patching and updating very, very key. You have to take note of that. Then continuing, change the user access control settings to always notify. Sorry, can you let me just give me some few seconds. Um, okay, change the user access control setting to always notify. So if it's changed to always notify, it will if there's any hanky panky or malicious activities going on, it will indicate. That's what always notify. Then restrict users from writing files to search paths for applications. So you remember you can do escalation by do either from unquoted service path or what's it called? replacing DLLs, injecting malicious DLL or dilib. So restrict users from writing file, continuously monitor file system permissions using auditing tools, reduce privileges of users and groups so that only legitimate administrators can make service changes, use whitelisting tools to identify and block malicious software, use fully qualified paths. That's what on quoted service paths. Um, then ensure that executables are placed in right protected directories. So if you have the right protected directories, no one can override them. In Mac operating system, make plist files read only. Block unwanted system utility or software that may be used to schedule tasks. Regularly patch and update. Very, very uh, important. So we have tools that you can use to defend against what's it called? DLL and daily hijacking that I just talked about now. Dependency worker detects many common application problems such as missing modules, invalid modules, import or export mismatches, and circular dependency errors. The daily hijack scanner, simple utility that will scan your computer for applications that are either susceptible to daily hijacking or have been hijacked. Dependency work and daily scan. And spread and meltdown vulnerabilities, patch and update operating system firmware, enable continuous monitoring of critical applications and services running on system and network, regularly patch vulnerable software such as browsers, install and update ad blockers and anti-malware software to block injection of malware through compromised websites, enable traditional protection measures such as endpoint security tools to prevent unauthorized system access, block services and applications that allow unprivileged users to execute code, never install unauthorized software access on trusted websites from systems storing sensitive information. Use data loss prevention solutions to prevent leakage of critical information from runtime memory. Then frequently check with manufacturer for BIOS updates and follow instructions provided by the manufacturer to install updates. Spectre and Meltdown Checker used for detecting Spectre and Meltdown vulnerabilities. All right, so we have another. We are moving to another level, as it were, when it comes to the issue of system hacking. We are talking about applications. Many attackers have to put in different applications in order for them to be able to exfiltrate data or to get data, even out of their target system or the places where they have put in with the systems that have been able to compromise. So when attackers execute malicious applications, so of course, without you see that we are taking it step by step. We talk about password cracking, talked about privilege escalation. Before that, we talk about buffer overflow. Then we talk about privilege escalation. Then we are now talking about executing application because without having administrator level access, uh, you can't do anything. You can't execute or applications. You can't install applications. So attackers execute malicious programs remotely, since information and distance position, loss of privacy, gain unauthorized access to system resources, hack the password, capture the screenshots, install backdoor to maintain easy access, etc. So malicious programs that attackers execute on target system include keyloggers, spyware, backdoors and crackers, keyloggers, spyware, backdoors and crackers. Mm, so backdoors designed to now disrupt the operation, gather information that leads to exploitation and gain authorized. So that those backdoors allow the attackers to be able to come into that system anytime they want. So it allows them to be able to come into that system anytime they want. Then crackers, they are used for cracking password or codes. Keyloggers, they capture key strokes. Um, they record keystroke made on computer keyboard. Then spyware, excuse me, they capture screenshots and send them to specified location defined by the hacker. So attackers have to maintain access to victims' computers. So after deriving all the requisite information from the victim's computer, the attacker installs several backdoors to maintain easy access to it in future. So talking about remote code execution techniques, how will an attacker be able to execute or remote, execute code remotely on those systems that he has been able to gain access to? So exploitation for client execution on secure coding practices in software can make it vulnerable to various attacks. Attackers can take advantage of vulnerabilities in software through focused and targeted exploitations with an objective of arbitrary code execution to maintain access to the target remote system. So, through vulnerabilities in software, through focused and targeted exploitation with the objective of arbitrary code execution. Then, service execution. System services are programs that run and operate at the back end of an operating system. So we have these system services, they run at the back end of an operating system. So attackers run binary files or commands that can communicate with the system services, such as service control manager to maintain access to the remote system. So they have service control managers that can be able to allow you to maintain access. So these service control managers, they communicate with the system services that are running in the background. And Windows management instrumentation, it's a feature in Windows administration that provides a platform for accessing Windows system resources locally and remotely. So this WMI is used by attackers a lot to perform a lot of things. So meanwhile, Windows or Microsoft put it there just purely to be able to administer their operating system both locally and remotely. But attackers take advantage of that feature. Attackers can exploit MR features to interact with the remote target system and use it to perform information gathering on system resources and further execute code for maintaining access. So they can use it to execute code. And Windows remote management, Windows-based protocol designed to allow a user to run an executable file, modify system service and the registry on the remote system. Attackers can use WinRM command to interact with WinRM, Windows Remote Management, and execute payload on the remote system as part of their lateral movements. So we have tools for executing applications. These are tools that you can use to execute applications remotely. We have Dameware remote support, a remote control and system management tool that simplifies remote Windows administration. So you can use it to, uh, for remote code execution. But for Windows, remotely manages Active Directory. So you can see host name, authentication type, user ID, password. Use Intel AMT KMT KVM. Connect to a remote Intel AMT KVM host using the remote frame buffer. Use this option to connect to remote system running on Intel vPro hardware. Ninja, Poppy, PDQ, Manage Engine Desktop, PSSEC. So for keyloggers, so keyloggers capture keystrokes. So if you are fortunate, or should I say unfortunate, to have a keylogger on your system, that keylogger will capture keystroke, anything you type on your keyboard, anything you type, it will capture it and send it to the attacker. So we have types of keylogger, we have hardware and software. So there are programs or hardware devices that monitor each keystroke as the user types on the keyboard, logs onto a file, or transmits them to a remote location. Keyloggers allows the attacker to gather confidential information about the victim, such as email ID, passwords, banking details, chat room activity, IRC, and instant messages. Physical keyloggers are placed between the keyboard hardware and the operating system. So a keylogger can record every keystroke that is typed, capture screenshots at regular intervals showing user activities such as type characters or click mouse buttons, track the activities of users by logging window titles, names of launch applications, and other information. So everything you carry out is always tracking it. Monitor online activity of users by recording addresses of website visitors with keywords entered. Record all login names, bank and credit card numbers and passwords, including hidden passwords or data displayed in asterisks or blank spaces. Record online chat conversations. Make unauthorized copies of both outgoing and incoming email messages. So these are all the things it can capture. These are all the things that the keylogger can capture. So we have hardware and the software keyloggers. We have PC or BIOS embedded. This one embedded on the personal computer or the BIOS. Then that's hardware keylogger keyboard. So these ones are when you have this keyboards, there is a cable that connects the keyboard to the CPU. So you put in the uh, keylogger first into the CPU before you now connect the cable coming from the keyboard. So that can only happen when you have direct access to the system. You understand? So because it's hardware. So external keyloggers we have. So we have PS2 and USB keyloggers. Keylog, just plug in a USB. That keylogger is on the USB. Then acoustic or cam. So this one just monitors the electromagnetic waves and sounds that come from the keyboard. Then Bluetooth keylogger sends via Bluetooth, sends all the keylogging details via Bluetooth to the attacker. Then Wi-Fi. So we have software, we have application, keylogger, kernel, keylogger, provides for form grabbing. This targets from forms, JavaScript-based keylogger, memory injection, keyloggers. So BIOS level firmware, this one is the PC or BIOS I was talking about. This are under the hardware, keystroke loggers. It's responsible for managing keyboard actions that can be modified. So that's BIOS level firmware, so that it captures the keystrokes that type. It requires physical access to the target computer. Then keylogger keyboard, sorry. So this one, you connect it uh, to the keyboard cable connector. The external include PS2, completely transparent to computer operation, requires no software or drivers, records all keystrokes typed by the user. So acoustic, it connects electromagnetic sound, like I said. Then Bluetooth requires physical access to the target computer only once at the time of installation. local Wi-Fi access point and send emails containing recorded keystroke data to the attacker. We have the software web application allows you to observe everything the user types in our emails, chats, and application. Kernel, please, if you have any question along the way, please feel free to drop the question in the chat box, please. Feel free to drop it in the chat box. Okay, we have so many others. Let's quickly run. Then we can have a remote collar keylogger attack using Metasploit. Attackers use tools such as Metasploit to launch persistent keylogging. Using the keyscan start command to initiate actual keylogging process on the target system. Then keyscan dump to sniff the keystrokes of the user. They can automate the entire sniffing and data dumping process using Metasploit lockout keylogger. Using the PS command to obtain the list of running processes and their process IDs on the target system. So to avoid closing and reinitiating the ongoing exploitation product, attackers migrate the current process ID to that of a running process, here explorer.exe. So migrate PID to explorer.exe. Migrate. We have hardware keyloggers, like we said. This is the key. This should be the, I think, is this the USB? Yeah, USB key logger, key grabber. Then we have other ones, USB key logger. This PS2, the one that record the PS2, I think PS2 stroke acoustic. The Wi-Fi connects to Wi-Fi. Hardware key logger. You connect it to the cable coming from the what's it called? The cable coming from the keyboard. Then there's one that is keylogger embedded inside the keyboard. Then Bluetooth keylogger transmits via Bluetooth. Then we have keyloggers for Windows. Pirate keylogger free is used for remote monitoring on your PC that includes recording of keystrokes, passwords. So if you install it on your PC, anyone that uses it, you can monitor the person. Pirate keylogger free. So you can see the screenshots. Everything the person entered was showing it. Then keylogger for Mac operating system, refog Mac keylogger. Provides undetected surveillance and records all keystrokes on the computer. So as shown in the screenshot, the attacker can use the revoking malware to record all activities on the target and still critical information such as login credentials. Other ones, Spyris, Elite Keylogger, and so on. Then we have spyware. So spyware it records the user's interaction with the computer and internet without the user's knowledge and sends information to the remote attackers. It's like a Trojan horse, which is usually bundled as a hidden component of free web programs that can be available on the internet for download. Allows the attacker to gather information about the victim organizations such as email addresses, user logins, passwords, credit card numbers, and banking credentials. So spyware captures everything, your screen, your camera. That's what it does. It's a spy. It records user interaction with the computer and the internet without the user's knowledge. So, how do people get infected with spyware? Drive-by download. You visit a website. Just by visiting the website, the thing automatically downloads on your computer, masquerading as anti-spyware. Some people will say, "I use this to get spyware out of your system," but once you download and install it, it's actually a spyware. Web browser vulnerability express. So there are some web browser vulnerability express that allows attackers to be able to get spywares infected with spyware. Piggyback software installation. There are some software you are installing, but spywares have come along with that. Then when you have browser add-ons like browser extensions, they can be a form of spyware. Then cookies also. So those are ways which get infected with spyware. So spyware can hyper attacker to perform the following: steal user personal information and send it to remote server hijacker, monitor users' online activity, displays annoying pop-up, redirect a web browser to advertising site, changing browser default setting and prevent the user from installing it. If you are, I don't know if you have experienced it before. Normally if you load your browser, there's a default page like my Chrome now, Google. It's called. It opens the browser. I mean the search engine. So, but I've experienced it using a previous system where as I log in, as I open it changed it, it changed the home page. So if it has done that, you need to check very well. Add several bookmarks to browser's favorite list, decreases overall system security level, reduces system performance, causes software instability, connects to remote pornography sites, places desktop shortcut to malicious spyware sites, steals your password, sends you targeted email, changes the home page and prevents the user from storing it, modifies the DLFs and slow down the browser, changes firewall setting, monitors and reports websites you visit. So spyware tools, spy tech, spy agent, and power spy. These are spyware tools. It allows you to monitor everything users do on your computer. That's it. Spy tech, spy agent. There are different types of spyware. We have video spyware, monitors everything. It's a video software for video surveillance installed in target computer without the user's knowledge. So all video activity can be recorded according to a programmed schedule. The video spyware runs transparently in the background, secretly monitors and records webcams and video IM conversions. The remote access feature of video spyware allows the attacker to connect to the remote or target system to activate alerts and electric devices and see recorded images in video archive, or even capture live images from all cameras connected to the system using a web browser such as Internet Explorer. So print spyware knows all the things you are printing. Telephone spyware gives you full access to monitor a victim's telephone or cell phone, as so on and so forth. How do you defend against keyloggers? Use pop-up blockers and avoid opening junk emails. Install anti-spyware antivirus programs and keep signatures up to date. Install professional firewall software and anti-keylogging software. Recognize phishing emails and delete them. Don't open phishing emails. Regularly update and patch system software. Do not click on links unsolicited or dubious emails that may redirect to malicious sites. Use keystroke interference software that inserts randomized characters. So if you are using this kind of software, even if the attacker gets your keystrokes, he will get it all wrong because it's inserting random characters into what you are typing. Scan files before installing and use registry editor or process explorer to check for keystroke loggers. Use Windows on-screen keyboard accessibility utility to tap password. So once you are using your on-screen keyboard, it will make it difficult for the attacker to be able to gain because key loggers recognize keystrokes that come in through your keyboard. But once you use your own screen or virtual keyboard, it becomes an issue. Install host-based intrusion detection system that can monitor the system and disable installation of keylogger. Use automatic form filling password manager or virtual keyboard to enter your username or password. Use software that frequently scans and monitor the changes in the system or network. Then hardware keylogger. How do you defend against that? Restrict physical access, of course. Make sure nobody has physical access, or make sure no malicious person has physical. Periodically check your keyboard interface to make sure no extra component has been added. Use encryption between the keyboard and its driver. Use anti-keylogger that detects presence of hardware keylogger such as key grabber. Use on-screen keyboard with a mouse. Periodically check video monitor cables to detect presence of hardware keyloggers. Set up video surveillance around computer desks. Set addition of malicious hardware. Disable USB ports or set up advanced BIOS authentication mechanisms to enable USB ports. Anti-keyloggers, the manner detects the malware at the time it attacks your system rather than detecting it based on a signature fingerprint. So this one, once it comes in, once the virus comes in, it detects it. It doesn't have to scan. It detects the malware once it attacks. It doesn't detect it based on signature. Most antivirus detects using fingerprint. Gadget ID, key scrambler, Oxinga, key shield, ghost press. How to defend against spyware? Avoid using any computer system over which you do not have complete control. Adjust the browser security settings to medium or higher for internet. Be cautious about suspicious emails and sites. Enable firewall to enhance the security level of the computer. Regularly update the software and use a firewall with outbound protection. Regularly check task manager and MS configuration manager. Regularly update virus definition files. So these virus definition files help you, because many people will have antivirus, but you don't update it. So if you are not updating it, the new viruses that are in town, so to speak, you will not know them. Even if they come on your system, they would have read the alpha before you can, because before you can say Jack Robinson. So install and use anti-spyware software. Perform web surfing safely and download cautiously. Avoid using the administrative mode unless necessary. Keep your operating system up to date. Avoid downloading free uh, music files, screensavers, or emoticons from the internet. Beware of pop-up windows or web pages. Never click anywhere on these windows. Carefully read all disclosures, including the license agreement and privacy statement before installing any application. Super anti-spyware. Software application that can detect and remove spyware, hardware, is not potential. They are software applications. Super anti-spyware to detect and remove spyware, hardware, Trojan horses, and other potentially harmful uh, software applications. So we have other tools: Kaspersky, Secure Anywhere, hardware, antivirus, mask, and content antivirus plus spyware. Can detect and remove spyware, Trojan horses, rogue security software, computer worms, rootkit, parasites, and other potentially harmful software applications. Then we'll come to rootkits. So rootkits are programs that hide their presence as well as attackers' malicious activities, granting them full access to the server or host at that time and in the future. So these rootkits, attackers use it to hide their presence on a system. They have gained access to a system. They use it to hide their presence as well as the attackers' malicious activities, granting them full access to the server or host at that time and in the future. So rootkits replace certain OS calls and utilities with their own modified versions of these routines that in turn undermine the security of the target system using malicious functions to be executed. So a typical rootkit comprises of backdoor programs, DDoS programs. That's DDoS. We'll still talk about that later. We have denial of service and distributed denial of service, packet sniffers, log wiping utilities, IRC bots, etc. So this rootkit, when attackers install it, it hides their presence as well as their activities. So they're able to do and undo. The attacker places a rootkit by scanning for vulnerable computers and servers on the web. So he now wraps it in a special program like a game, installing it on public computers, corporate computers through social engineering, then launching zero-day attack, privilege escalation, buffer overflow, Windows kernel exploitation, etc. So those are the way that attackers places a rootkit. Wraps it in a special package like a game, installs it on public computers or corporate computers through social engineering, launch a zero-day attack. So when we talk about zero-day attack, we are talking about attacks that have not been, how do I put it? This kind of attacks, they have not yet been discovered, or how do I put it? They have not, or even if they have been discovered, the no countermeasures have been found against such kind of attacks. You understand? So they are still relatively new and unknown. The objectives of a rootkit to root the system and gain remote backdoor access. That's one of the things. So he wants to be able to anytime he wants. It's not every time the attacker will now start going through all the trouble he went through in the first place. You understand? He wants to be able to ease into the system anytime he wants. So that's why he installs the rootkit, which is a form of a backdoor for him to just be able to access the system anytime he wants. So it's not going to start doing information gathering, um, scanning for vulnerabilities, or what's it called? Password cracking, previous escalation. No, 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 no. You can't be doing that all over. So that's why it installs the backdoor. So to mask attacker tracks and presence of malicious application, that's rootkit. They also have just to gather sensitive data, network traffic from the system to which attackers might be restricted or possess no access, to store that malicious program on the system and act as a server resource for bot updates. So those are the reasons why the rootkit might be there. We have types of rootkits. We have so let's say maybe in the next 8 minutes we should be through. Well, I think we started late. So just in the next 8 minutes we should be through. So we'll continue, and I believe we'll be able to complete this module tomorrow and move on to another module. So types of rootkit, we have hypervisor level rootkit. It acts as a hypervisor and modifies the boot sequence of the computer so as to load the host operating system as a virtual machine. So this kind of rootkit, instead of the host operating system to load as the host operator to now load as a virtual machine, of course, the rootkit will be able to control it. Then hardware or firmware rootkit hides in a hardware device or platform firmware that are not inspected for code integrity. Kernel level rootkit adds malicious codes or replaces the original operating system kernel and device driver codes. Bootloader level rootkit replaces the original bootloader with the one controlled by a remote attacker. Application level stroke user mode rootkit replaces regular application binaries with fake Trojan or modifies the behavior of existing applications by injecting malicious code. Library level rootkit replaces the original system codes with fake ones to hide information about the attacker. So this is how rootkit works. So we have before hooking, this is the process. Maybe an example of a process. in a computer. Then after hooking, it replaces, you can see kernel 32, it replaces it with something else. In the direct kernel object manipulation, you have the process ID. Before rootkit, after rootkit infection, you have F-link, B-link, process identifiers, list entry. So it's the direct kernel object manipulation rootkit hide the process by unlinking it from the process list. It unlinks it from the process link. We have the popular rootkit. We have popular Fox and Moonbounce. Popular Fox and Moonbounce. Sorry, Purple Fox and Moonbounce. Purple Fox and Moonbounce. The Purple Fox rootkit can be distributed via a fake malicious Telegram installer. Supported 2-bit and 4-bit Windows versions of the Purple Fox Trojan can be used for hiding within the system and maintaining persistence. So it can be used for hiding within the system and maintaining persistence. Then Moonbounce, malicious code concealed within UEFI firmware in SPI flash that is scheduled to be executed at a specified or specific time. The purpose of Moonbounce is to inject a malicious driver into the Windows kernel during the boot process, providing attackers with maximum persistence. So how do we detect rootkits? Is that through integrity-based detection? So at maybe when the system is freshly set up, we have what we call create images of the file system. We have snapshot of the file system, boot record, and memory. So that's the what we call the baseline. So later, when we suspect an infection, we cannot compare, because the way it does is that the way we create this snapshot, if there's any little change, just one bit of change, you will see it that something has changed here. So if you want to detect a rootkit, you can use integrity base. So you have a trusted baseline when the installation was done afresh. Then you compare it with what you now have, and you see if there's a difference. There's been a rootkit infection. Then signature base. So if you have rootkits that maybe you have the signatures. So if there's a scanning, if you have scanning done, then if it will detect the signature of the rootkit and it will pick it up. Uh, so the technique compares characteristics of system process and executive file with a database of known rootkit fingerprints. So if you have known rootkit fingerprints, you can just use to scan. When you scan, if you can find it there. So it's just like antivirus scanning. It's all based on signatures. So they have their each thing is, I mean, virus has its own fingerprint or signature. So it's based on that. If you identify anyone based on the signature fingerprint, then you will now know that yes, there's an infection. Then heuristic or behavior based. So any deviation in system normal activity indicate the presence of a rootkit. Runtime execution path profiling compares the runtime execution paths of all system processes and executable file before and after. So there's a path through which there's the applications or processes are executed. So if there's any deviation, you know that there might be an issue. Then cross-view based detection enumerates key elements in the computer system such as system files, processes, and registry keys, and compares them to an algorithm used to generate a similar data set that does not rely on the common API. So any discrepancies set indicate the presence of a rootkit. And alternative trusted medium. So you can boot the system or the computer from another from an alternate medium, maybe a CD or a USB, to find traces of rootkit. They analyze memory looking through the random access on RAM. The suspected system is analyzed to detect the rootkit in the system. So those are the ways you can detect the rootkits. So steps for detecting rootkits: run the RSBAH and the RSBAH inside the potentially infected operating system and save the results. So boot into a clean CD, run their SBH and their SBAH 808 on the same drive and save the results. So run a latest version of WinMatch on these two sets of results to detect file hiding ghostware, invisible inside but visible from outside. So yeah, what you do is that you are trying to create like an image of everything about the system. Create an image about the system. So you look at what obtains, then you now boot onto a clean CD. Well, when you are booting onto a clean CD, you are not booting the operating system that is infected. You understand? So you also create an image, then you now compare. Use WinMatch to compare if there's any change. So how do we defend against rootkits? Finally, for today, reinstall of OS application from a trusted source after backing up critical data. Maintain well-documented automated installation procedures. Perform kernel memory dump analysis to determine the presence of toolkits. Adding workstation or server against attack. Educate staff to avoid downloading files or programs from process sources. Install network and host-based firewalls. Ensure availability of trusted restoration media. Update and patch operating system application and firmware. Regularly verify integrity of system files using cryptographically strong digital fingerprint technologies. Regularly update antivirus and anti-spyware software. Avoid logging into an account with administrative privilege. Adhere to the principle of least privilege. So least privilege is you don't give anyone what is, for instance, if somebody is in accounting department, don't give him the access to HR or admin. So that's least privilege. Give somebody the only what is necessary to do his or her work. Ensure the chosen antivirus software possesses rootkit protection. Avoid installing unnecessary applications and disable features and services that are not used. So we have GMA and anti-rootkit. GMA, it detects and removes rootkit by scanning processes, thread modules, and services and files. Okay, I think we'll just have to continue from here tomorrow. It's an interesting part. It's an interesting alternative, data stream. Let's continue from here tomorrow.